What if one half of the moon is hiding something deep beneath its surface? Something so different, it could rewrite everything we thought we knew about lunar history. NASA's GRAIL mission uncovered a startling mystery on the moon's far side that has scientists scratching their heads. This isn't just about craters or shadows. This is about internal differences, ancient forces, and maybe even untapped secrets. The moon has always been part of our night sky, but most people don't realize we've only ever seen one side of it. Thanks to a phenomenon called tidal locking, the moon's rotation and orbit match perfectly, causing the same hemisphere to constantly face Earth. For centuries, the far side remained a complete mystery. But when spacecraft finally captured images of that unseen half, the difference wasn't just visual. It hinted at a deeper, more mysterious reality. While the near side of the moon, the one we see, is marked by massive dark plains known as lunar maria, the far side is dominated by rugged highlands and a dense network of craters. This imbalance raised major questions. Why would one hemisphere be smooth and volcanic while the other is rough and untouched? The answer, as NASA would later reveal, lies beneath the surface. The near side is thought to have experienced intense volcanic activity due to internal heat, which allowed lava to fill and impact basins and create the smooth maria. Meanwhile, the far side shows almost no evidence of this resurfacing. The GRAIL mission confirmed these suspicions. NASA's data revealed that the far side has a thicker crust and lacks the heat-producing elements, like uranium, potassium, and thorium, that are found in abundance on the near side. These elements generate heat through radioactive decay, which likely fueled volcanism in the moon's past. The fact that these differences go beyond surface features points to a larger story, one involving the moon's internal evolution and perhaps even the influence of Earth's gravity early in its formation. Understanding this asymmetry isn't just important for lunar science. It's a vital clue in uncovering how celestial bodies develop and why they don't always evolve symmetrically. NASA's GRAIL mission may not have made headlines like a crewed landing, but its findings have been nothing short of groundbreaking. Instead of taking samples or photos, GRAIL used the subtle power of gravity to peer beneath the moon's surface and uncover its hidden structure. Launched in 2011, the mission deployed 2 spacecraft, nicknamed Ebb and Flow, to orbit the moon in close formation. Their job? Measure tiny changes in the distance between them to map gravitational variations. As the spacecraft flew over denser or less dense regions, the pull of gravity would slightly alter their spacing by just a few microns. These incredibly precise changes were recorded and analyzed to reveal how the moon's mass is distributed deep below the surface. The results painted a striking picture. On the near side, some areas of the crust are as thin as 30 kilometers, while the far side's crust can reach over 60 kilometers in thickness. This thickness isn't just a physical trait. It reflects how much heat could rise from the moon's interior. The near side's thin crust allowed lava to flow to the surface more easily, while the far side's thick crust trapped that heat below, stifling volcanic activity. GRAIL also confirmed the near side is enriched in radioactive elements like thorium, uranium, and potassium, which produce internal heat over time. That heat likely drove the massive lava flows that created the lunar maria. Another clue came from the South Pole, Aitken Basin, a colossal impact crater on the far side spanning 2,500 kilometers. Despite its size, it lacks lava flooding, underscoring how little volcanic activity occurred there. In essence, GRAIL showed us that the moon's 2 faces aren't just different. They're fundamentally unequal in how they formed and evolved over billions of years. The discoveries made by GRAIL aren't just fascinating. They're essential to how we understand the moon and, more broadly, planetary evolution. This newfound knowledge of the moon's internal imbalance has deep implications for science, exploration, and future missions. First, it challenges the assumption that planets and moons cool evenly and symmetrically. The moon's near side, with its thinner crust and higher concentrations of heat-producing elements, remained geologically active far longer than the far side. Meanwhile, the far side cooled more rapidly, preserved its rugged surface, and lacked the same internal heating. This contradicts many long-held models of planetary thermal evolution. Second, the difference in crust thickness and heat flow has practical consequences. NASA's Artemis program, which plans to return humans to the moon by the late 2020s, needs detailed knowledge of the surface and subsurface to plan safe landing zones and infrastructure. Sites near the South Pole, for example, may be affected by subsurface temperature gradients and terrain structure, data that GRAIL helps clarify. Third, the distribution of radioactive elements like thorium and uranium could hint at valuable resources hidden within specific lunar regions. While lunar mining isn't imminent, the possibility is being studied seriously. Knowing where these elements are concentrated could shape future extraction strategies, or influence where permanent lunar bases are built for energy efficiency and material access. Finally, the moon's far side is considered a prime location for placing advanced radio telescopes due to its natural shielding from Earth's electromagnetic interference. But building observatories in such remote regions requires a clear understanding of seismic stability, thermal profiles, and subsurface support, all informed by GRAIL's data. This is more than a scientific curiosity. It's a foundation for the next era of lunar exploration, where knowing what lies beneath is just as important as what lies ahead. NASA's GRAIL mission has shown us that the moon is far from uniform. It's a split world, with hidden clues buried deep beneath its far side. These revelations challenge old assumptions and open new paths for exploration. As the Artemis program prepares to land humans on the moon once again, the questions raised by GRAIL will guide future missions, both robotic and human. What secrets still lie beneath those ancient craters? We're just beginning to find out. If you enjoyed this video, don't forget to like, share, and subscribe for more updates on space exploration and scientific discoveries, and don't forget to leave a comment below. Thank you for watching, and see you next time.